Great morning, afternoon, or evening, mini mathematicians. This is Video Bar going over 6.1b homework, the rational number system. So let's take a look. I know some of you might be confused about on 13, 14, 15, and 16. So remember, we're going to want to start an equation, using an equation to rewrite these. Although some of them we may be able to use our slick trick. Remember, you can use your slick trick of over 9s if all the digits after the decimal point are being repeated, like 0.45 repeating. All those digits after the decimal point are being repeated. So let's just go back really quick to the directions to make sure we can use our slick trick. Directions. Change the following decimals into fractions without the use of a calculator. Show all your work. So here, because on 13, we do have all the digits being repeated, I can use my slick trick. How many digits are being repeated? 2. So that means this is 45 over 99. However, of course, we need to think about, is this the simplest form? What number goes into both of these? Well, it's 3, because 4 plus 5 is 9. If the sum of the digits is divisible by 3, then the entire number is divisible by 3. 4 plus 5 is 9. 3 goes into 9, which means 3 goes into 45. Let's see. So we're going to divide by 3 to our numerator and denominator. 3 goes into 4 once, the remainder 1. 3 goes into 15 5 times. So this is 15 over, 3 goes into 9 3 times, and 3 goes into 9 3 times. Let's double check again. 5 plus 1, 6. 3 goes into it. 3 plus 3, 6. 3 goes into it. So let's do 3 again. Oh gosh darn, I could have just done 9 from the very beginning. Oh well, maybe next time I can check that. 15 divided by 3 is 5, and 33 divided by 3 is 11. So we know that 45 repeating is equal to 5 11ths. We could always grab a calculator to double check that 5 divided by 11 is indeed 0.45 repeating. And you can also use common sense. 5 over 11, is that more or less than a half? It's less, just a little bit. So let's move on to 14. Before we move on to those, let's think about from problem number 11. Let's really quick look at those. If you're working with a non-repeating decimal, this is a terminating decimal, so I know it's rational. I can write this as a fraction. So I just have to think of how would I say this. This is negative 64 what? Tenths, hundredths, thousandths. And then from there, you can continue simplifying, just in case you got stuck there. Okay, let's go back to those repeating decimals, because those are so much more fun. Let's take a look at number 14. Number 14, can I use my slick trick of over 9s? Let's look at this. Are all my digits after the decimal point being repeated? No, just that 3 over in the tenth, hundredths, thousandths place. So what I'm going to do is I'm going to use my equation. For an equation, x is equal to 0.083 repeating. And now I need to make sure to cut off just my repeating decimal part. Well, to do this, notice I move my decimal point over 3 times to get to the end, but there's 2 decimal places here that I don't want to really worry about. So I want my repeating decimal to line up here. Well, let's try 10 and see what happens. If I multiply both sides by 10, you end up with 10x equals 0.83 repeating. Let's see, if I subtract x from this side, and from this side, that would be subtracting 0.083. What number's here? Is it a 0? Oh, wait, that bar means this is also a 3 repeating. So when I subtract, these 3 repeatings will cancel out. So now you have 9x equals, well, this is just something like 83 cents take away 8 cents. You could borrow, if you wanted to, borrow 1 from the 8, make it a 7, or you can think about you had 83 cents and spent 8 of it, or $83 and spent 8 of it. If I had $83 and I spent 10 of it, I'd have 73. But I didn't spend 10, I spent 8, which is 2 less, which means that would be 275. So now, to get x by itself, I need to divide both sides by 9. When I do that, I end up with x equals 0.75 over 9, which is not a rational number because rational numbers are ratios with integers, and 0.75 is not an integer. In fact, we would never leave decimals inside fractions. So from here, let's multiply both numerator and denominator. Well, let's make it easy and do it by 100. Move the decimal over twice, and we'd have 75 over 900. From here, let's think about how can we simplify this fraction completely. How about 25? 25 goes into both of these numbers evenly. 75 divided by 25 is 3. 25 goes into 100 4 times, so it goes into 909 groups of 4, which would be 36. From here, 3 also goes into 3 and into 36, and your final answer would be 1 over 12. 1/12. So I'm just going to double check that. Since I don't have my answer key, I'll put 1 divided by 12 in my calculator. And take a look, 0.08 when that 3 is repeating. Whoop! I'm so excited. Okay, so from there you should be able to practice 15 and 16. Best of luck, and I will see you later. Bye.